Okay, we are in a discussion of AWS Solutions Architect, and we've been discussing about different topics in my previous videos. So, the previous video we discussed about AWS API Gateway, and today we're going to discuss a bit about AWS CodeBuild, right? CodeBuild is more basically towards development sites. So basically, it's belong developer side, right? So let's have a look. What is this code build, which is automated continuous integration, right? Okay, so AWS Code Build is fully managed continuous integration service that automates build, test, and packaging of software getting ready for use. It scales with your need to relate high quality software quickly and reliably, serving as a critical component of AWS CI/CD ecosystem, right? Continuous integration, continuous deployment, right? Uh, Ecosystem. Okay, let's start to looking into what is this code build, right? Okay, so just going to give you some sort of a real world example. What is this code build? How e-commerce platform build process works, right? So I'm going to compare a bit of traditional coding approach, whatever we have been doing from 19th up to today, and what is the AWS code build approach, right? So as a traditional coding approach, so developer manually build and test code on a local machine. That's what we've been doing before we deploy in production. So you install all environment available needed for coding, like you use a different sort of software, like the we've been using long time ago Visual Studio, and then you just install that Visual Studio environment. Or if you want to do coding in Java, so you install Java environment and set it up for ready for testing codes, and then you do testing code in there, and you use debugging, and then you correct errors and run. You keep running a code until you get without any errors, and then when the code is ready, you're going to deploy it in a production environment. So that's what it says. So you use local machine, and then the developer write codes locally, manually run build command, right? So then run test on their local machine, and then once it's ready, you upload into whatever the server is running a production environment, and then you manually deploy it to production, and then you're going to monitor for errors after post development, right? So this is like a very high uh, you got a risk having a lot of errors because it's actually the environmental different, right? So you possibly are setting up all environmental variables in your local machine. It might be a bit of a different in your server environment, maybe using to develop in a Windows client environment, and then you're going to put it into a server environment. So might have human errors. So the new code build approach by AW is right. So that's basically developer commit the code. So code build automatically build, test, and deploy. So developer commits code to GitHub, right? So you're using GitHub. GitHub, you got all the versions, the codes, and everything, right? And then use code build automatically triggers via webhook, right? Webhook, and then you use configuration file, right? Run build spec.yaml file, YML, right? And in a Docker container, right? And then execute automated test in a, consistent environment, right? And then pushes article to S3 ECR automatically. And then we're going to talk about code pipeline deploys to production, and then CloudWatch logs provide real-time visibility. So the time is 10-15 minutes per release, low. The consistent environment and automated validation gives you so much advantage over traditional method of code building. So if this is highlights in this one, so your environment you use in a GitHub, right? GitHub, and then use webhook, and then you runs build spec file in a Docker container environment, and then you pushes them into S3 ECR automatically, and then use code pipeline to deploy to a production environment, and then errors and log level things CloudWatch. So the advantage here is you have a consistent environment and automated validation. So that is the difference, right? So if we go with a, sort of a, what do you call in a summary, so aspect the build time in traditional is a one builder 2 4 hours. It's a 10-15 minutes automated. Environment consistency is a similar environment in a code build. Traditional environment it's a bit of varying in between different production and developers environment, and then error detection after post deployment, and then here the chance is you got a pre-deployment automated test, and then a release frequency. You can release them multiple times a day, comparing with weekly or monthly in a traditional, right? So infrastructure cost is fixed, always on servers in a traditional. Now it's a variable because you only pay for whatever you use normally, right? Right. So, the overview, we're going to have a look core concept, understanding code build architecture and component, and then we're going to looking into CI/CD pipeline integration and workflow automation, and then a build configuration, build specification, and environment setup, and then what is the best practice optimization and security strategies for code build environment, right? Okay. You're looking into a code build timeline and roadmap in AWS, right? Which is initially identified, introduced in 2019, the code build launch, and it gives you initial features at that time. And then 2021, they have enhanced support, so Docker image updates, and then 2023 is developed up to advanced features and integration improvement. So 2024 and currently current state and optimization. So project setup define build configuration and source, and then build execution, compile and testing code, and then deploy into production environment. All right. So if you're going to look into a bit of the environment similar to code build, right? So we've got a few of them in here in a comparison table. So you compare with the price, complexity, integration, scalability, and customization. So you have four different uh, code build environments. So the first one is the AWS code build. The second one is the Jenkins. The third one is the GitHub Actions, and then GitLab CI, right? So code build you pay per use, right? So Jenkins is self-hosted environment, and then the GitHub actions you have free and paid tiers. GitLab CI also you have free and paid tiers. The setup complexity is low because it's a managed service, and then Jenkins is high, self-managed. Uh, GitHub, the low integrated with the GitHub, and then the other one is also low complexity. So AWS integrations have native integration with the other AWS services. Uh, Jenkins, you have to use plugins, uh, actions, GitHub actions via third party, the GitLab CI also via third party. So scalability here, code built automatic scaling, Jenkins manual configuration, and then GitHub actions and GitLab also have facilities of automatic scaling. So here the one of the disadvantage here is a limited customization in the code build, and then Jenkins is extensive customization. So it's one of the extensive customized tool. The Git of actions and GitLab actions is in between Jenkins and code build, which is good, right? So that's how comparison table with the sort of different environment, right? Uh, we get to talk about code build, core functionality and mechanism, right? So what code build does is code build automates the build and then test and the packaging of software in a Docker container environment, right? Build mechanism is execute command specified in the build spec file YAML format, right? And then configuration define the build and test is the automated processing of the source code, right? So here the source code and input code builder Docker and build a spec and then output. So you can get a output product for testing, right? That is how normally code builder works. Key features build environment flexibility, right? So the flexibility of building environment in a code build providing it's a managed environment, right? So see that you can use pre-configured Docker images for Java, Python, Node.js, .NET, Go, and Ruby. Like you can think of if you're going to use locally building these different environment, how hard you have to set up the environment in one single local machine. So this is actually a ready environment, right? Custom Docker images, so support for custom Docker images to meet specific project requirement and specified frameworks, and then customization, flexible environment setup combining managed and custom Docker images for optimal control, right? So you use Docker image to deploy this environment. The key features monitoring and management, so real time status updates, immediate feedback on build progress and execution status, enabling quick identification issues. So detailed build logs, so you can use CloudWatch logs to provide comprehensive debugging and auditing capabilities for build process. And then you can use again the notification service SNS integration alert to build events including success, failures, and other status changes. Visibility centralized monitoring dashboard that tracks all build metrics and historical trends for better decision making. So you have a lot of controllable elements integrated with this one to making easy to life of a developer. So real-time status update, detailed build logs, build notifications, and visibility. So integration points within AWS ecosystem. So code build. What are the major services integrated with the AWS other services? So S3, right? So you have S3, right? And then ECR, we discuss ECR, Elastic Container Registry, right? So you can use store Docker image during build process for seamless container management. And then going to talk about code pipeline, automated end-to-end continuous delivery workflow, orchestrating CI/CD stages for from build through deployment, right? So these are the services integrate majorly with this code build. So integration, right? So CI/CD tools and network access. So CI/CD tool the integration. So AWS code pipeline orchestrate the code build within automated workflows, right? So third party support. So they are compatible with external tools, including Jenkins and Circle CI for flexible CI/CD pipelines. I think they are through third party softwares. Um, enabled organizers to integrate code build to existing to tool chain investment, right? And then we're looking into security side and network support. So VPC integrations run built within the virtual private cloud for secure and private network access. And then internal resources access on the on-premises systems and private AWS resources without internet exposure. So that's for private access. So without exposing these ones to internet, and then security maintain network isolation while enabling resource communication, right? The architectural benefits. What are the benefits in this architecture? That's the speed and reliability, right? Increase build frequency, automation, enable releasing new features multiple times a day through continuous integration and practice. So this become very easy to change features and deploy them quick method rather than traditional way, releasing more frequency of your version, improved reliability. So it's because of your using the same platform, same environment. Actually, when you are deploying the software, so that make less errors and more reliability, right? It's not like something you develop in a local machine going to deploy in different environment. This is the same environment you're testing. Reduce risks, automated testing, minimize risk of releasing buggy code through comprehensive validation. Remember when we doing this separately, you have to do QA and testing, extensive testing, QA, a lot of things. Most of them are nowadays within that environment. So you can use the same environment for uh, whole testing. So visibility and scalability, the next one, right? So detailed monitoring feature including logs, notification, and dashboards. So quick identification and solving. So you can see the CloudWatch logs and SNS notification for failure, success, or the situation. And then you can have a dashboard shows you all everything like versions and the history of your process, right? Scalability. So it's automatically scale capacity to meet peak build demands, eliminating manual server management over. So you don't need to get more resources that will automatically scale, right? So see, just a table just gives you a self-managed environment versus code built environment, right? So you could see what are the difference. So automatic scaling based on demand, scalability, and then maintainers fully manage zero maintenance. So you don't need to maintain your development environment here. So they are the sort of different between the modern code built environment versus self managed environment, right? Let's looking into code build user cases and scopes, right? So multiple languages it supports. You could see so many languages currently we are using. It's supported like Java, Python, Node.js, .NET, Ruby, numerous other programming language frameworks, and application from my small website to large scale enterprise with complex multiple environments or deployment support on premises, cloud, hybrid environments with flexible architecture. So today's once you build these codes, they're possibly going to uh, compatible with the other environments, large cloud service providers like AWS, Azure, Google. They all provide this sort of environment. So you probably can switch between hybrid environment. That's another advantage. They might provide the same multiple language support, right? Okay, so if you're looking into a summary and exam focus points, key takeaways here in today's video. The code build is a critical, fully managed continuous integration and CI/CD suite. It's eliminate infrastructure management overhead for your developers, right? Um, Core concept for AWS exams of build spec YAML configuration files, the Docker container build environment using integration with S3, ECR, and code pipeline, and then VPC support for secure build. You're looking into performance optimization, artifact caching. So this support caching S3 to significantly speed up subsequent build by reusing the previously compiled or download dependencies of build performance, and then cost efficiency. The other factors just need to concentrate on if you're getting some exam, right? So future directions for AWS code builds of feature and trend to watch. These are the features and trend to watch. So emerging features. So today's world, AI powered build optimization. So going to be integration with Amazon Code Group for intelligent code review and build recommendation. See that it's like one of your partner, they showing what are the weaknesses and maybe a strong points in your code, right? And weakness points, something like that, enabling automated detection of vulnerabilities during the build process. See that this is one of the features going to come to you because normally when you build something, we only going to know some vulnerabilities in the past, like someone like hacker or someone get into the program and then all right, so we got this weakness and we're going to release a patch or something. But this AI powered build optimization possibly going to give you a sort of an idea in beforehand before you deploying this one, and then telling, hey, you're possibly going to have a vulnerabilities in this code. So also it's probably going to suggest you what you need to do to avoid that. And secondly, like if you're thinking of processing, it's like um, uh, bottlenecks performance bottlenecks you're going to have when you are actually deploying in the um, production environment. So how do you going to do? You have to do multi-threads environment or whatever is going to be AI build feature going to suggest you code building in the future. So the other one is enhanced observability, deeper integration with the CloudWatch and AWS X-Ray, comprehensive tracing and performance analytics. So entire build pipeline. So that's a monitoring capability, debugging. So native support for container registers. So expanded support for additional container registries beyond the ECR, right, including Docker Hub and private registries. So going to support so many different container registries, right, private registries and some other like third-party registries. Industry trends and adoption. So GitOps integration, so enhanced support for GitOps workflows and declarative infrastructure management, right? When you're providing an infrastructure as a code. So security first, CI/CD. So shift, increase emphasis on shift left security practice in built-in vulnerability scanning and compliance checking during the build phase. So this is a good thing. You can find out what are the problems in the build process before you deploying into a production environment. So as I said earlier, can do multi-cloud because a lot of clouds supporting the same building environment. So a lot of organization doesn't want to be stuck in one cloud. So might be your code might be compatible with some other cloud environment if you're not happy with the current one. So performance reduce build times through advanced caching mechanisms like parallel execution improvement, GPU acceleration for compute in intensive builds, artificial intelligence, machine learning models, right? So this is the key areas of advancement coming up. So it's going to be, I think, the development environment going to be a lot of easier than whatever hard time we had like a developer. It's going to make developers' life easier, right? I didn't know one day it's the AI going to take over developers' life, but so a lot of things going to be become easier. So if you're looking into future outlooks, the AWS CodeBuild is positioned to evolve into an increasingly intelligent, secure, and integrated CI/CD platform. Convergence DevOps. Maybe you only need to give a step like a flow chart, what you need to build. So it can build the whole environment in the one day. Who knows, right? That's wherever we are heading to. So cross-platform orchestration organization should monitor AWS announcement for new capabilities, AI-powered optimization, and enhanced integration with the emerging AWS services, right? So if you're looking into a roadmap, this is where I got it's from, right? I think going to look into as we always do a little bit real world scenarios involving code builder. You probably seen in my uh, other videos. So this is like maybe the exam you consider, right? So scenario one, automating a multi-language build pipeline. Uh, a company develops micro services in Java, Python, Node.js. They needed continuous integration solution that handles different build requirement without managing multiple build servers. So that's code build, right? So you just need, if you're using a single machine, so you have to configure all three environment, right? So to Java and then you Python and then Node.js. So all three environment, but CodeBuild is a readily available platform, so you can use each language integrated with the code pipeline to orchestrate builds, leverage manage Docker environment to each language. So that's where one of the questions. Securing private builds in VPC. So that's we discuss. Uh, CodeBuild you can isolate with VPC. So even if you have on-premise environment, right? So you can use them without exposing to internet. That's how it's work with the private build. And optimizing build performance with caching. So build times are slow because dependencies are downloaded separately for each build. Right? Solution is enable S3 artifact caching in build spec YAML file, cache dependency directory. So that is how S3 cache, right? Uh, make build performance faster, slow builds, right? Then probably get integration with private container registry, right? Custom Docker image must be pushed to a private ECR. So configure build spec YAML to Docker build and push commands. Use IAM role to grant code build permission to ECR. Integrate with code pipeline for automated deployment. That's how you integrate this one with the uh, container registry, private container registry. All right, guys, I think this is one of the like a subtopic in whatever our discussion. So I think this is what's about code build. Hopefully, you have got some sort of basic idea is what a code build is looks like and how it's evaluated from a local initial traditional environment, which we use a local machine to build our coding and doing our coding and then deployment to production environment to AWS code builder, which is a readily available environment with all the testing capabilities and troubleshooting capabilities within it into a modern world. I think this concludes my video for today. Um, I will see you guys from another video. Until then, thank you very much.